All right, so we're going to solve a non-homogeneous differential equation by using a new method called variation of parameters, which is a very formulaic solution to this kind of a differential equation. We first get the homogeneous solution, which seems to be a common step among all methods for solving second order differential equations. But then what we're going to do is, so since the homogeneous portion it's a combination of two functions, y1 and y2, we're going to say that yp, the particular solution, is some variable multiple of y1 and y2. And now you understand where we get the name variation of parameters from. So it's, like I said before, it's very formulaic. u1 is going to be an integral, so is u2, as you can see there. F of x is the function on the right-hand side. So in general, we're talking about a differential equation of this form. P and Q are functions of t, and on the right-hand side, we have our function f of t. So this f corresponds to the function that's on the right. Notice that the coefficient of y double prime has to be 1. If it's not, all we do is simply divide through by whatever coefficient that is. So, and another thing you're going to notice in the formula is this w. The w stands for the Wronskian, which is this determinant for the two solutions y1 and y2. And remember that we know that the Wronskian is never 0 if the two functions are linearly independent, which they wouldn't be a general solution if they were not linearly independent anyway. So sounds like we're safe to go. So looking at this example here, we have the differential equation y double prime plus 10y prime plus 25y equals e to the negative 5t divided by 1 plus t squared. And I don't know why this n is here, so let's just get rid of that. And first things first, we find the homogeneous solution. Now we know the left-hand side is constant coefficients, so we're just going to solve this the old-fashioned way. And we have lambda squared plus 10 lambda plus 25 equals 0. This means lambda plus 5 squared equals 0, which means lambda equals negative 5, but repeated, which means that impacts our general solution. We have c1e to the negative 5t plus c2te to the negative 5t. So right there are our y1 and y2, right there. Okay, so now we're going to say yp has the form u1 y1 plus u2 y2. And yes, this does matter. Order does matter. So we have to make sure that we keep everything defined the same way throughout the entire problem, or else we're not going to get the right answer. So first I'm going to do is find the Wronskian, which is the determinant from the original homogeneous solutions. And then we take the derivatives to get the second line. So derivative te to the 5t is e to the negative 5t minus 5te to the negative 5t. And then we just multiply, subtract, and multiply. So multiplying top left to bottom right, we have e to the negative 10t minus 5t e to the negative 10t. And then subtracting the product from the upper right down, looks like it's plus 5t e to the negative 10t. And that's just e to the negative 10t. So look at that. Nice, simple Wronskian. Okay, so now u1, the multiple of y1 in the particular solution, is the integral of negative, now y2 was te to the negative 5t. F is e to the negative 5t over 1 plus t squared, and this is all over e to the negative 10t dt. Now this looks terrible, but things cross out. E to the negative 5t times e to the negative 5t is e to the negative 10t. So divided by e to the negative 10t, it just goes away. So we're left without the exponentials. So you have negative t over 1 plus t squared, which after a u substitution would give us negative 1/2 natural log 1 plus t squared. And remember, we don't need the arbitrary constants because all that's going to produce is more terms that overlap with the homogeneous solution. So that's our u1. Now, U2, not the Irish band, U2 is the integral of, now it's y1 e to the negative 5t times f, all divided by the Wronskian. And again, it looks disgusting, but things do drop out. So we are left with dt over 1 plus t squared, which you might remember is your arctangent. And again, no plus c. So this means that the particular solution is u1, y1, so negative 1/2 e to the negative 5t times the natural log of 1 plus t squared plus u2, y2. So I'm going to write this as t e to the negative 5t arctan of t, and that's our particular solution. And then y is equal to the homogeneous plus the particular. So I'm just going to write it that way. We have the homogeneous up above. It's actually right up here. So you're just going to add the C1 and C2 terms to this long particular solution. And there we have it. That's the solution to our differential equation. So as you can see, variation of parameters, very systematic, very formulaic. All we have to do is just be able to crunch through those integrals. So not always the best method to use, but when you don't have another option, it's the way to go. Thank you for watching.